Okay, so for this example where we're going to again show different way to perforate this based off of a parameter, it's going to be slightly different, but again, it's going to require us to divide the surface by a bunch of points. Again, I'll keep the U value around 30 and then the V value around like 350 for now. So something to understand is before we flatten this, we can see that we do again have branches of points. And so we can actually begin to organize our points or create parameters for those points based off of our list lengths. And I'll show you how this starts to work. So if I just look for a list item, it's defaulted to look for the item index 0, so the first set of points. You'll see that it's in fact looking at this very first column of points. If I were to give it a slider, we can see how it just basically goes from the very first and then it starts working its way all down. And if we want to look at it the other way, we can flip this matrix. And you'll see that now instead of looking at them as columns, it'll actually look at them as rows, right? So based off of this approach, by flipping it and looking at rows, we can essentially start to split this to create a pattern based off of a graph mapper. So that's what we're going to do for this video. So instead of just looking for us at a single row, we're actually going to look at this entire kind of set of points and just decide, you know what, I want to split this row or this column here, maybe split that one there, split it. So it basically is going to follow that graph mapper. And you can see by using the split list component here, I can essentially say use this a certain index for each one of those. So again, I'm going to go to parameters, input, graph mapper. I'm going to go to sets, sets, range of values. So in this case, I'm looking at every single column, so whatever that V value is. So I'll drag that into there. Change that graph type to, I don't know, let's use something like the sine curve. So basically, we're going to use this to start to split it. And so in order to kind of, again, whatever, if I decide to change my U values, I want it to all respond accordingly. So I'll just use the math and multiply this by whatever that U value is. So this now becomes, again, this where we have to be careful or you're gonna kill your script if you aren't careful. So instead of, again, that flat, we want it to also graph it. And that'll solve that issue. So again, it shows both areas that split. We're just interested in the list A. So again, I'm looking at points. So I'm going to use the point component and turn this off, as well as this part. And let's turn our lofted surface back on. So we can start to see basically how that list is starting to get split based off of this pattern, right? So I probably don't want to go all the way up it, so I can have these kind of interesting patterns though. Right, if I want it to look a little more kind of organic, I can go to graph type, maybe use the Perlin one. Okay. split it that way, make it maybe a little bit smoother. I can have various gradients, right? They're all slightly different. We can kind of shift it even down a little bit. I can make it really kind of large like that. Regardless, we have some interesting patterns. So again, maybe the idea is that you can now take these points, again, flatten these, since I'm just going to treat them all the same now that I've kind of split them this way. What I want to do now is, again, kind of give them some size. So maybe, again, if this area is kind of solid, then it makes sense to go from very small to large ones, and I'll use that based off of their z coordinates. So I'm going to go to vector, deconstruct these, look at their z values, and choose their size that way. So again, I'm going to remap them. So I don't want their z values to represent the radius of these circles. Before I go any further, again, I need to apply these circle CNRs to it. So just like how I split this list of points, right? I've got that, but I need their direction as well. So what I want to do is copy and paste both of this and also do it for this N output. So now I'm using this one. Now I'll use again the A value and flatten it. Drag that into the N. And again, I kind of want to figure out what's the max height I can go without there being too much overlap, and most likely these are going to be at the very bottom, so you can see that there's still significant overlap that way. Maybe I want to increase my U value. So again, I know they're going to get small, and again, I can always kind of continue to mess with this until I'm happy with the results. So let's turn off these points so I can see that a little better. And again, I'll kind of use this to dictate my new range of values. So I'll construct a domain. Again, the higher, the smaller. So we'll do 0 as our B value and 0.26 as our low value. And that becomes our new radius, right? So again, as they get really high, they start to shrink. Doesn't look like there's a whole lot of perfor or overlap too, which is great. Pretty happy with that result. So now again, what I might want to do that I haven't shown the others is that we can always filter out these values too. So we don't have to look at every single one. So maybe these really small ones, want to make sure that we don't get those really kind of microscopic ones that wouldn't be very beneficial. So I'll stay in the math, look for values that are larger than a certain radius. So in this case, something around 0.01, or let's do 0.10. I'll use the sets, list, dispatch, use the larger than or equal to that value, look at the curves for just the list A again. I can see that probably filters out too much. Maybe just one more. I think that should be okay. So now we're just left with 3,600 something circles. So yeah, that's how we can get, again, using a graph mapper to create our perforations. Again, I can continue to mess with this until I get the pattern I want. If I want to do it the opposite way, I can do that as well. So maybe I'm looking at list B now, instead of list A. So I'll just go ahead and lock this since I'm going to be changing a lot. Let's flatten that too. So if I want to go the opposite way, I can do it like that as well. In this case, maybe they start off large, so I'll just flip these around. All right, those values might be a little too much, so we can always drop those down till we get this, again, kind of cascading quality, which could also be really interesting. So yeah, again, another unique way on how to use a different type of parameter of filtering out these points by their sets or index using a graph mapper.